So I had a phone call ending the last session, so we're going to try it again with this one. Establishing identities, second part of section 4 of chapter 7. These we're going to need to use our even odd identities, and so those are on your blue sheet. But let's just go ahead and try to start these and see what we can do. So first of all, sine squared theta, negative theta, will be the same as negative sine theta squared minus cosine of negative theta is this just the same as cosine theta. So that's the numerator, new numerator, and then in the denominator we're going to have negative sine theta and then still minus cosine theta. So we want those negative angles to get to be positive angles. Well, negative sine squared, negative times negative, is going to give us sine squared theta minus cosine squared theta over negative 1 times sine theta plus cosine theta. Okay? Okay, so now we can factor the numerator, and the numerator will factor as it's a difference of squares, so it's sine minus cosine theta, I should put the theta, and sine plus cosine. Okay, so divided by negative 1 times sine plus cosine. So this part cancels, and you're left with negative 1 times sine theta. Oops, I'm out of room. So let me go up here. So you're going to have negative 1 times sine theta minus cosine theta. And then when I distribute the negative 1, you'll end up with cosine, it's negative sine plus cosine, so I'm going to list the cosine first. And so the left side now matches the right side, which is, again, when you establish identity, that's what you want to do. Okay, next. I think that was a sheet I put in there for me to work. So here's another example, and I tried to put a lot of examples in here. So what are our strategies? Well, one of the strategies here is going to be to make that cosecant, change everything sine and cosine, and we only work with the left side. Well, cosecant is 1 over sine theta times cosine theta, and that's going to equal cosine theta over sine theta, which is cotangent theta. And so now we've proven the identity because the left side equals the right side. That one was fairly straightforward. Those are the nice ones. Okay, let's go to the next one. All right, so for this one, we're going to have cosine theta. Whoops. So we have cosine theta, and we're going to change tangent to sine theta over cosine theta, plus cotangent is cosine over sine. Now this is the way I would do it, but there's an easier way to do it, but this is the way I did it first, so I'm going to go ahead, and then that equals cosecant. So I'm going to get a common denominator in the parentheses, which means I'm going to end up with sine squared theta plus cosine squared theta over cosine theta plus sine theta. Well, all of that numerator is 1. So, oh, excuse me, that's times, not plus. So now I'm going to have cosine theta over cosine theta, sine theta, cosines cancel, and that's 1 over sine theta, which is the same as cosecant theta. Okay. So that's one thing that the first thing that I did when I was going to solve it. Now their strategy at the book, I think, is shown on the next slide. No, I guess I took it out. But there's an easier way to do that, I believe. But that one works. So let's look at 1 plus tan u over 1 plus cotangent u to see if that equals tan u. Maybe this is the one that has the easier one. I did sine and cosine again. That's usually the place I start when I start to do an identity. So that becomes then 1 plus sine u over cosine u over 1 plus cosine u over sine u. Okay? Now we've got to get common denominators. So that becomes cosine u plus sine u over cosine u over sine u plus cosine u over sine u. Then you're going to invert and multiply. So you're going to have cosine plus sine over cosine times sine over cosine plus sine. Okay? And then that cancels, and so you're left with sine over cosine, which is the same as tangent. And so they two sides match. All right, I cut that off a little bit early, but hopefully you can go back and stop it if you need to look at that a little longer. I didn't leave it on the screen very long. So let's go. This is how they did it. They didn't change it to sine cosine. They did change cotangent to 1 over tangent and then got a common denominator there, which works out pretty well and is a little bit simpler than changing everything to sine and cosine.
Teachers, please follow the mirror.
All right, so now we've got secant minus 1, secant plus 1 equals tangent squared. Okay, and that's another one that's actually pretty straightforward. If I multiply those, since this factors, that's the difference of squares factorization, that's the secant squared minus 1. Okay, and secant squared minus 1 from your trig identities is tangent squared. So that's just, once you multiply them, you can just get that trig identity from your blue sheet. Okay, let's move on. All right, 1 minus sine v over cosine v plus cosine v over 1 minus sine v. This one I thought was a little tricky. Well, first I got a common denominator. So I'm going to multiply the first one by 1 minus sine v. So what that ends up being is 1 minus sine v, all of that squared. And then I'm going to multiply the second one by cosine v, so that's now going to be squared. And then our denominators are just multiplied, so it's cosine v times 1 minus sine v. And so that's how a way to get a common denominator. Now if I multiply that whole numerator out, and let's see if I have room for it, I'm going to have 1 minus 2 sine v plus sine squared v plus cosine squared v. All of that over cosine v times 1 plus, or excuse me, minus sine v. Okay. Now, if I look at this part of it, sine squared plus cosine squared equals 1. So now I have 1 plus 1, or I have 2 minus 2 sine v over I'm sorry, I keep having people come in and out and I punched the wrong button. So I erased all of that. But I'm going to put what we had up to that point. And so if you need to go back, hopefully you can. So I've got 2 minus 2 sine v over cosine v times 1 minus sine v. All right, now I'm going to factor out a 2 in the numerator, which means I have 2 times 1 minus sine of v over cosine v times 1 minus sine v. And then the sine v's cancel. So you have 2 over cosine v. And cosine is the same as 1 over secant. Excuse me, 1 over cosine is the same as secant. So that's the same as 2 times secant v, or 2 secant v. So I've made the left side match the right side. All right, so moving on. Again, that was fairly complicated, I thought. So there's only a couple more, I think. Let's move on. This one is tangent v plus cotangent v, secant v over cosecant v times equals 1. And I'm going to first change everything to sine and cosine. So I have sine v over cosine v plus cosine v over sine v. All of that over 1 over cosine v times 1 over sine v. And all of that equals 1, supposedly. All right, common denominator. In the numerator, you end up with sine squared v plus cosine squared v over cosine v sine v. And all of that's over 1 over cosine v sine v. So when I invert and multiply, the denominators are going to cancel each other out. And all of this is equal to 1. Sine squared plus cosine squared is 1. So really now what we have is we have 1 over cosine v sine v times, and I invert the denominator, cosine v sine v over 1. So everything cancels, and so all of that equals 1. And so we've established an identity. All right? And there's an explanation written out. All right, so now we have 1 minus sine theta over cosine theta. And we're supposed to, hopefully that will equal cosine theta over 1 plus sine theta. All right. So in this case, I'm going to multiply by, again, using some of those strategies they talked about, I'm going to multiply everything by 1 plus sine theta. And I do that so that I can have a difference of squares that I can multiply there. So I'm going to multiply 1 plus sine theta over 1 plus sine theta. Okay. And so this becomes in the numerator 1 minus sine squared theta over cosine theta 1 plus sine theta. Alright, so 1 minus sine squared theta is the same as, so I'm going to go up here, 1 minus sine squared theta is the same as cosine squared theta over cosine theta times 1 plus sine theta. One of the cosines here cancels that one out. So you're left with cosine theta over 1 plus sine theta. Alright, so that's 21. And I think there may just be one more example. So let's go to the next one. That's an explanation if you want to do that. They show it pretty much the same way. Now, we've got secant minus cosecant over secant times cosecant equals sine theta minus cosine theta. So let's look at that one. All right, so, okay, we're going to change it to sine and cosine. So secant is 1 over cosine minus 1 over sine theta over 1 over cosine theta times 1 over sine theta. Alright, so the numerator now becomes sine theta minus cosine theta over cosine theta sine theta, and all of that is over 1 over cosine theta sine theta. So we're going to multiply the two fractions, divide the two fractions, so we invert and multiply. So times cosine theta sine theta over 1. These cancel, and so you're left with, that's a minus, so you're left with sine theta minus cosine theta as your identity. Okay, so that's some examples. Hopefully it's enough for you to start work on your homework. And the last slide is simply a summary. Always preferable to start with a side containing the more complicated expression. Rewrite sums or differences as quotients or as a single quotient, in other words, common denominator. Sometimes it helps to rewrite them in terms of sine and cosine only. And always remember where you're going. So as you manipulate one side, you keep in mind what you want to have, what you ultimately want to get, because you want it to match the other side. So good luck. Homework 7-4. Mr. Speck can help you if you need help.